Hey, today I'll be speaking about symptom-based alerting for machine learning. So first, I always like to tell people why they should listen to the talk or what they will learn. So the talk is useful for you if you still want to skip to the other track. If you're a backend engineer or SRE, if you want to monitor a machine learning model, so let's say some of your data science team is now, okay, we make it to production, here you go. And you want to use easy existing tooling and to detect quality issues that are not covered by backend monitoring, and I will tell you why. Okay, so who am I? I'm a machine learning consultant and freelancer. I've been doing it for 11 years. I mostly work with tech startups, and I used to work at Zalando. Shout out to the SRE team and to the Zalandos. And I run roughly 30 models in production so far, developed them, deployed them, run them. Recommendation systems, personalization, NLP, customer service, finance, travel, range of models. Okay, so that's the agenda for today. First, we will talk about backend monitoring, which is our foundation. So just to see if when I'm coming from the outside as a machine learning engineer, if we're on the same page, and then how you add ML monitoring and what tooling you can use for it. Okay, so let's start with the basics of backend monitoring. So, of course, I will recommend to use the 4 golden singles, so classical backend monitoring, latency, traffic, errors, saturation. And what I learned as an ML person is that you focus on symptoms, meaning end user pain, and not root cause, because it's more upstream. And when you capture end user pain, you know it has an impact on the user. Then you put everything on a dashboard. You alert if the metric is too high or too low. By the way, this is very interesting for if you have a data science team and you want to give them a primer, they usually don't know this. So to bring the 2 areas together when you have to run something in production, I'm always giving them this intro. And of course, we have logging, so you can add machine learning specific logging here. So you can alert on the logs, like was the model correctly loaded? How did the inference go? And now the question is this enough if you have a machine learning stack? So on the left side, you see a classic stack, you have unit tests, integration tests, you have system monitoring. And on the right-hand side, you see a machine learning application, which has additional complexity. So you have the machine learning infrastructure that trains the model. You have the model itself that is trained and redeployed. You have the training data, then the data in production, which can diverge from each other if they are not coming from the same data source, which is often the case. And then you have the predictions. So it's a bit more complex. This is from a very good paper called the ML test score from Google, where you can score the production readiness of your ML stacks. So I wanted to give you some concrete examples that I have experienced in my time running ML stacks of silent failures that you wouldn't detect from backend monitoring. So the typical question, what could possibly go wrong if we just have the normal monitoring and have an ML model? So for example, we had a fraud model and someone changed the unit of one of the input variables to the fraud model. So for example, how long a user is doing something on your page, and it changed from seconds to milliseconds. So there was no exception, still exactly valid input, but all the outputs, of course, of the model are entirely wrong, lots of fraud downstream, and you maybe only notice a lot later. Another time we had a case where we were a recommendation team and we used an article enrichment service that we called to get article information as an input to the model, and they switched their technology stack. So they just gave us a new endpoint, now use this one. But they had some data loss during the migration in some fields that they didn't notice, but we used this field for filtering. So we suddenly had a lot less output. Another example is aggressive post-processing rules after your machine learning model. So maybe you have a field that can be sometimes empty, and originally the field is filled 80% of the time, and then you put something in production, it looks good, and over time, this field is less and less filled, and then at some point it's only 20% filled, and whatever you're filtering is very aggressive. Another example, we had a filter for on-sale articles that looked very good when it was not a sale season. So you can have all kinds of these issues. Of course, you can have bugs in your own code. As we all know, bugs happen regularly. So actually one of the main things for the machine learning monitoring was that we had bugs in our own application code. For example, that generated inputs, that added fields. Model was automatically trained and released, but was worse. So there were no quality checks on the model. And we also had cases, if you're in a big company, that your client that calls you changes the way their application area works. So for example, before you had to be logged in to see this feature, suddenly they make an improvement, don't talk to you. You don't have to be logged in, so you get an entirely different type of users, different type of data. And the interesting part is that this is silent and it's often permanent, these degradations. So your ML team with highly paid people work for 5 months to improve something by 4% with a big lever, but your operational monitoring is not there and you lose 15% of response quality because there's some filter going rogue or something like that. So it's very important commercially that this type of monitoring is present, and it has a lot of impact on your bottom line. So now that I've motivated why you should add additional monitoring, let's talk about how and what exactly. So I regularly joined the SRE guild at Zalando to learn a little bit more on operational stuff, and I learned this concept that you alert on systems and you focus on end user pain on your monitoring. And what I try to do is transfer this to machine learning and think about what does this mean in my domain? How should I do it? And I gave this a whirl 8 years ago. And here's this typical sequence of a machine learning request. And then we try to map it to end user pain. So first, the request comes in, you have a request payload. Then typically we add data to it, like user history, article data, whatever it is in your domain. Then you call the actual machine learning model. Afterwards, you have some post-processing rules, and then you return a response, and probably you also record a user interaction. And to the right, you have more user impact, and to the left, if there's a change, it's more unclear what the user impact is. So what I deduced was end user pain is best detected in the later step, so you should prioritize your monitoring on the outputs of your service. This is very interesting because whenever you read machine learning literature and blogs, they all focus on data monitoring, data input monitoring, drift in the data. But I found that this is not very good to detect issues because if one of your 70 input fields changes and now has a different median, like who knows what impact this has on the quality of your outputs. So I suggest that we start focusing our monitoring efforts on outputs first. And here I map a few candidates that you could monitor. We'll talk one by one through them. So let's start with the right-hand side. The first obvious candidate for me was evaluation metrics in production and stakeholder concerns. So since you guys are not machine learning people, so let's quickly elaborate what is an evaluation metric. That's the metric that we use during the training of the model. So this could be something that you maybe even know, precision and recall, could be a ranking metric, NDCG, could be accuracy. And the data scientists I talk to are usually super confused that you should be able to monitor this in production because it's an unknown concept. They only measure this in training when they have the ground truth. So this begs the question, how do you actually do this? You can do this if you have a machine learning use case where you get to know the ground truth data, usually with a bit of a delay. So let's say you have a food delivery service and you want to show your customer the predicted delivery time. After roughly an hour or something like that, the food actually arrives and you can compare your prediction to the ground truth value and calculate whatever you calculated during the training of this prediction model, let's say mean error. And there are a lot of applications like this where you have, with a bit of a delay, the ground truth. There are also some challenges in this. So a lot of machine learning applications have, for example, an unknown ground truth. So if you have a fraud model and you say, stop, this is fraud, don't let this user through, and you block them, then you don't know if this was actually fraud. So how it's typically solved is a lot of companies let through a really small percentage of their fraud just to check the model is still working. You can also have a delayed result. So when I was at Zalando, or Amazon, very similar, you deliver a package and you say the package is with you in 3 days. Then you have to wait between 2 and 4 days to see when it actually arrived, so it could be delayed. And you can have a filter bubble effect. So if you have a recommender system and you only show certain items and suddenly the algorithm goes rogue, shows different items that are worse, the user never saw the better items, so you don't really know what the ground truth was. This means you can do this for some machine learning areas and applications, but not for all of them. And for the ones where you can do it, how do you do it in practice? So you store your prediction and you somehow attach to the system that has the ground truth. And then you calculate with a batch job, or you have maybe an endpoint that receives the feedback, and you calculate these metrics regularly and put them in a dashboard and you create an alert. This is very uncommon. Not a lot of people use this. So this is like, even the MLOps frameworks slowly only add this. So I recommend you do this. This is a live dashboard I had when I was at a bank for loan applications. So I had a small holdout where I had recall and precision, and I could have a live alert. A second priority one is stakeholder fear signals. When we introduce machine learning, we usually think of the upside. What do we want to improve? But a lot of the people responsible for the actual product are also worried that you might make something worse, the reputation risk, something is not working. And to establish trust and have the machine learning running long time is always useful to talk to them and ask them about their worst case scenarios and put these in a metric, because machine learning is not guaranteeing just the implementation, it's somehow guaranteeing some sort of business success. So it is worth bridging that gap when you ask them, what do you think could possibly go wrong? What are possibly fuck-up scenarios? And you put these fear into metric because you don't want the users to experience them and you don't know. So, for example, when I was working at the bank, they were obviously worried that we would wrongly reject loan applications. So I made a precision dashboard that we discussed which precision was useful. And they were also worried that adding a machine learning component would make it slow. So we had a special discussion on what the latency should be. So it's always worth asking them not only on the upside, but talking to them about the downside and making specific monitoring boards that alert you in real time. Because again, you can't just tell from the application being up and responding that it's working. So priority 2 would be the service response and the model predictions and quality. So here it's important to understand when you, both for yourself as well as when you talk to the machine learning contacts you have, that there are 2 types of metrics. So the name metrics means something different in our domains. So when you talk about metrics in ML, that usually means the quality, and they are kind of objective based on what you wanted to solve with the algorithm. And then there are metrics that are used for monitoring. And we are very familiar with that on the SRE side, that we think, okay, monitoring KPIs are not the objective quality. So don't fall into this mindset when you now monitor ML that you want an objective quality metric for your machine learning model. You, as usual, just need something that is going down when the quality has an issue. So you just have basically a detection metric, let's call it like that. So second priority is, if you don't have the ground truth in production and can in real time monitor it, I recommend you monitor the service output. So after all processing rules, and to give you an example what this is, if you have a machine learning model, it can be, for example, fraud, not fraud. You usually have a prediction score, so you have a distribution of a number that you can monitor. If it's a regression problem, like a forecast, you also have a number. If it's an LLM, you have text. So basically, you monitor the outputs of the service or metrics that you derive from these outputs. And this is super cool because it's a catch-all technique. You don't need to connect to any downstream other maybe unreliable or slow or not available systems. So it's very low effort. It's also able to detect smaller changes. So let's say you want to see if a user thumbs up or down, or you want to have click rates. These click rates are very noisy. So let's say only 3% of users click on something. That's a much harder to monitor signal than if you have 100% of your responses. So you see even small drops, like 5%, 10%, you can often see if you monitor the output response. And this is much easier to do in real time. How do you monitor it? There are rule-based distance metrics like median, quantiles of the distribution. You can also have, for example, a share of insufficient or bad responses, for example, empty, or in your case, you might know what a bad response is. And if that's not enough for you, I would start with that because that's easily supported in typical monitoring systems. And if you want a whole distribution comparison, you can have a Kolmogorov-Smirnov test, or from the Google paper on data validation, the D1 metric, or population stability index, often used in finance and marketing. And what this is, it sounds fancy, but it's usually just distance metrics, distance comparison metrics. So you have two distributions in T1 and a distribution in T2, that's the darker one, and then you just compare them. So here you can visually see in group 1, the bar got a little bit higher, so there are more people in this bucket now, and in group 2 a bit less, and you sum up these differences. So basically, did this distribution change from our reference point, for example, from training or from yesterday or from last week? And then you can alert on that. A second thing you can do with the output is quality heuristics. Like I said, you don't need like an objective quality indicator, you just need heuristic that goes down if there is an issue. So for example, when I was in recommendations, I did something like really good or bad responses, like in how many cases do we have at least 4 items from the personalized recommender? So very simple. Or a bad response is in what percentage of the responses do we have empty or fallbacks? I also was in a talk from Spotify once, and they said they have an indicator ranking for their homepage, which is your most used box that you always click. Let's say you always click on, I don't know, 80s music or reggae after work. And it follows that if it's a personalized recommender, your most used box should not be very low down. So they have this as a running real-time thing. It doesn't tell you absolutely if all the recommendations are great, but it's a good quality indicator. No, it started running. It was stopping. I was about to ask. Okay, then we have priority 2, which is you do the same thing for your inputs, the inputs into the model and your training data. And this is especially great for root cause analysis. So let's say your output changed, you got an alert, this changed dramatically, why? And then if you have input data monitoring, you can quickly check there. So I would add this as a prio 3. And maybe one exception to that is a bit different. Usually there's a skew between training and serving. So when you bring the model live for the first time, I never had any case that didn't have data that should be the same data in live and in training, which was quite different. So you have to do this at least once, maybe even have an ongoing job that monitors the input data live versus the training data. So this is priority 1. But otherwise, priority 3. Okay, so how do you actually do this? So do I need an MLOps monitoring tool? There are a lot of cool tools now on the market. It's a hot area. And I talked and interviewed some people who had introduced such a tool. One is a friend of mine, a data scientist, and she reported that they introduced a tool and they suffer from what they don't know, but we call alert fatigue. So they have a lot of alerts that mean nothing. And they don't know how to address them. So usually it's like, okay, field 3 changed by 20%. So then, okay, please investigate. And then they don't know what caused it. They concluded well, it's an upstream business change, or maybe it's unexplained because a lot of input data in ML just fluctuates naturally. So before you go and say which tool solves my ML observability problem, you first have to figure out a lot of more organizational challenges, which are, what are your requirements for your ML use cases? It's not exactly the same when you run, like in backend engineering. ML is like backend. It's a huge, broad range. So it's very different if you have a financial application that does loans, or if you have your vision detection. So what are your requirements for monitoring? Who's addressing these alerts? Like, for example, if it's a backend or SRE person, are they even able to debug data-related issues, model-related issues? Are the data scientists on call, yes or no? And who is resolving during business hours? So in my team, we had this discussion. We were always on new projects as ML scientists. There was no protocol that we should do ops. So how is that solved? And the other question is, if you then detect a data issue, who's owning the data in your, like, it's very clear who owns this type of data, and also what's the priority to fix. So then we told the other team, listen, in this field, it drastically changed. We think it's a problem. And then they asked us, can you quantify how much money you lose? Like, of course not. Unless you run an A/B test with a fixed data source and a not fixed data source. So it's a question, how to prioritize in your org? Because for a lot of other teams, data is just a byproduct of what they do. So how do you prioritize these fixes? It's no point like alerting in them and finding them out if no one knows what is the priority to fix them. So what I recommend you instead is you slowly ramp up, right? So if you have a pure data science product and you start from scratch, maybe you can look into a full-featured solution. But typically what we have as a case is that there is an existing company that has already monitoring in place, an alerting solution in place. So I recommend that you start with your existing tools for monitoring and alerting, like you have Prometheus, you have Grafana, that type of tooling, and you can just start with that. That has the advantage that you can start immediately. It's often sufficient. You start with that output-oriented alerting. And later, when you find that you do a lot of ML-related debugging and you graduate, then you can have both the org is ready and you know what you need to buy a full-featured solution. And you can grow into it slowly. So also, of course, we want to have some code. Here's just an example in Python. So you can just have a Prometheus histogram metric on the output score of the leftover items after all post-processing. And if you have a complicated calculation, you want to compare whole distribution, you just log this response to storage somehow, maybe with a queue to S3, and then you run a script every 3 minutes or every 10 minutes to calculate, and then you have dashboards and alerts. So it's very simple. You can get started like this if you basically have understood what the priority is for ML monitoring. So to sum up, you need the golden signals, you add machine learning monitoring on top, and you prioritize the output metrics like response monitoring, and if you can, evaluation metrics in production. And you don't actually need a new tool. You can start with your existing tool stack, and you add a few metrics and you gain experience over time. Okay, you can talk to me if you have more questions on how to do this exactly. I am available for networking, questions, consulting, and I also recommend you a cool Slack. It's an MLOps Slack for people running ML in production. So if you find yourself in this position, it's a nice resource to exchange. Thank you.